Hello everyone, today we're going to talk about how data communicates within a network segment and what the communication process looks like. So, if we look at the diagram here, we have two computers and a switch. If our requirement is for host 1 to access host 2, the host is in an initial state. That is to say, I only know my own IP and MAC address. So in this case, let's assume it already knows the other party's IP address. And our switch here has just been powered on, meaning it is in an initial state. If we want to proceed, let's first review what we have discussed before. Before we send out our entire data, we first need to encapsulate our information into our data packet. This includes what we initially have here. After the data is generated, I need to add the transport layer encapsulation. Then add our network layer encapsulation, equal. When we reach the second layer away, we need to encapsulate it with our Ethernet, including its header and the authenticity of the Ethernet. In this context, if it is necessary to encapsulate our original MAC address and the destination MAC address, they need to be properly filled in and encapsulated before we can send them. However, during this process, we might not know the other party's MAC address. To encapsulate the data packet, my host will try to find out if I know the other party's MAC address. It will search itself in this context. A local table called the ARP cache table records the corresponding relationship between our IP address and MAC address. In the initial state, the ARP table in our host is empty, meaning there is nothing in it anymore. Similarly, for a newly powered on switch, its MAC address table is also empty. So, if our computer initially does not know whether there is a PC2 in the network, nor does it know what the MAC address of PC2 is, at this point it will choose to send an ARP broadcast to request it, meaning it will use the known IP address to request what the MAC address is. During this process, it will be sent from our PC1 to PC2. Now, in this process, when our switch receives a broadcast, it will perform a flooding action, meaning it will send a copy from each of its remaining interfaces. And here, when data is received from this interface, I will place it into my own MAC address table. And during this process, we can see that an entry is added to the MAC address table. The MAC address is the MAC of our host 1, and our interface is receiving from the 09001 interface. It will be recorded here, I, and after it is recorded, when it is broadcasted out, our host 2 will definitely receive it because it is connected to this switch. After receiving it, it will need to reply. The ARP message reply is in the form of a unicast. Let's take a look at this process. Now here, the main character 2 is responding. In this process, the response message is a unicast message. The sender is our MAC2, and the sender's IP is IP2. Who is it sent to? To our MAC1, and the destination IP is also our IP1. Now in this process, it is sent in a unicast form. The switch receives a frame from the J002 interface, and it will place it in its MAC address table. Here, we can see that this is our PC2, meaning host 2's MAC address. Additionally, we can see from which interface it was received, which is our 002 port. So after it is sent to the switch will help with forwarding. At this point, it checks whether the destination MAC is in its table. When it checks its MAC address table, it finds that the destination MAC is already in our table, and it corresponds to our interface G001. Well, if it is in the table, the action it chooses at this point is to forward. It will specifically send from this G001. Now, what if it's not in the table? After sending, host 1 will record it in its ARP table. The relationship between the IP address and the MAC address A is stored in our HCIA ARP cache table in the future when it looks for our PCR again. In this process, it will use the MAC address table inside, including IBA, to complete the encapsulation. For example, in the future, if PC1 wants to ping, at this time it can encapsulate its own original IP address, which is its IP1, and the destination IP address is in this process. It is this which will be placed in our encapsulation. Besides this, the original MAC address is its own. Therefore, although we can smoothly encapsulate MAC 1 here, the destination MAC address is in this process. We mentioned earlier that through our ARP query, including the response from host 2, it will learn that the MAC address of host 2 is our MAC 2. In the future, it can smoothly proceed from our single wave form. It sends a packet like a pin through the switch to achieve forwarding, and our switch here, because it has already learned the MAC address table, can also help us with forwarding. The switch mainly looks at our MAC addresses using the destination MAC and source MAC in the received packet to achieve forwarding. The source MAC might be recorded in its own MAC address table. But what about the destination MAC? In this process, it queries the MAC address table to see if it exists. If it exists, it forwards the packet. If not, it broadcasts it directly, without checking the address table. As for future scenarios, where a packet comes from this interface and needs to be sent out from the same interface, in such cases, I would implement a discard. This is the working principle of a switch. In the entire layer 2, we actually use MAC-based forwarding to help our data reach the other side and achieve communication. This is the communication process at layer 2. If in the future you want to learn about Huawei certification technology or wish to obtain the Huawei certification question bank, please send a private message. I can also leave more comments below the video for technical exchanges. So, this is the content of our course today.